Here, we have a motor. Motors are fascinating little devices that spin when provided an electric current. Let's figure out how to properly use one in our next project. The most common motors you will likely encounter are DC brushed motors, which can be identified by their two power connections. Getting this type of motor to spin can be done by directly connecting them to a battery. And if you flip the polarity, it will spin in the opposite direction. Sounds simple enough. I want to control this motor with a microcontroller like an Arduino. However, we cannot simply connect a motor to the output pin and expect things to work, because motors consume quite a bit of power. Let's take a look at the datasheet of a typical motor. As an electrical engineer looking at motors, we are only really concerned with three numbers: its rated voltage, rated current, and stall current. The rated voltage is the voltage at which the motor was designed to run at. Its rated current is the amount of current the motor can safely pull continuously without damage, and its stall current is the absolute maximum amount of current that the motor will pull, like if you were to physically prevent it from spinning. As you can see, all these numbers are significantly greater than what an Arduino pin can provide. So what do we do? Well, just like how you are probably too weak to push your car at highway speeds, you are strong enough to push on a pedal and let an engine do that work for you. The same concept applies here. The microcontroller is too weak to directly drive the motor, but it does have enough strength to turn on a switch that will allow something like a battery to do the heavy lifting. Obviously, an Arduino does not have fingers, so we use an electronic switch called a transistor. Make sure the transistor you select is rated for at least twice the voltage of your battery and twice the rated current of your motor, both of which you can easily find in the transistor's datasheet. Let's get a transistor and wire everything up. When we tell the Arduino to turn on its output pin, the motor turns on. Perfect. However, if we try to turn it off, the transistor immediately gets destroyed. This is because motors exhibit a phenomenon called inductive kickback, which is when the coils in the motor generate an extremely high voltage right when you try to turn it off. If uncontrolled, this voltage can reach dangerous levels where even high voltage transistors will still fail. Luckily, the solution to this problem is very simple, and involves adding one extra diode in reverse parallel to the motor. Now watch what happens. When the motor turns on, all the power flows through the motor and the transistor, and the diode remains off due to the reverse voltage being applied to it. However, as soon as the transistor turns off and the motor starts kicking back, a positive voltage is suddenly applied to the diode and turns it on, dissipating the extra energy, controlling that voltage, and protecting your transistor. Great. Now you can turn on and off a motor with a microcontroller. But that's boring. What happens if you want to control the speed of a motor, or make it spin backwards automatically, or go really fast? Perhaps you want to know why the motor kicks back. More of that to come. Stay tuned.